Hello, everyone. I am really glad to be here, and I'm glad all of you came to talk. To talk to me later. I hope so, but to listen to this. We, like I was saying before, this is Inception themed, so it might be fun if you've seen Inception before. But I do know that many of us in this audience are very hardworking security people, and for that reason, it makes it kind of heartbreaking, makes it difficult to see when developers ghost security or don't cooperate. We see a lot of friction in between security and development. But, and sometimes it's just hard to work together. This wouldn't really matter if development operated under any sort of security principles. This would kind of alleviate our stress level. But the fact is they really don't care about our security principles. So the thought process is, wouldn't it be nice if we could just plant the inception of security into the developers' minds and have it be their idea to produce security, like mind control in the title, make it their idea, and so that it's motivated that way. And this would be a bit of an impossible mission. So what I'm going to walk you through is the research and planning that might be required in doing something like this. And really what I want to show you is that dreams pay. So the first thing that we're going to do is we're going to talk about first principles, and then we're going to design an implant, specifically show you how to do it for your environment. And we'll start by looking at a model for application security, for software engineers for application security. And then we'll talk about some practices for development. And then we'll drill down to one key aspect that are a key activity that we'll want to perform. Just real quickly about myself. My name is Elton Crossley. I'm a product security consultant for GuidePoint Security. And I have some certifications, but more importantly, I have about 20 years background in software engineering. And I do have some network engineering experience back there too. And up there, I highlighted it for some reason. I spent my adolescence on the security bulletin board systems, the early 90s. And really what that does is brings up another question of why I got into development instead of security. Because at that time, there really wasn't too much going on in the security realm, but the way that I saw things coming together, it kind of turned me off about security. In fact, this morning we talked about how the security environment has changed over the years. The industry has, or the hacker community has changed, and it's really a different time than it was a couple of decades ago. And so at that time, I saw some things that I enjoyed doing in software engineering, and I saw that it is a very subtle art and a discipline to be developed. And so I was attracted to that. I thought I'd spend some time there and learn it. And it seemed like I blinked my eyes and I had been doing it for 2 decades. And hopefully, the reason I mention all of this is hopefully I can bring a bit of my understanding to help each one of you out to reduce friction and to deal with some of these scenarios. So if during the talk today, I do have my own opinions, but if we don't go over anything that helps you, or it may you may have questions, I would be happy to entertain those. And I love to hear your guys' experiences and your stories. And I'll be hanging out outside the room afterwards to talk about some of those things, so I can get your perspective more or less. So the first thing that I want to do is be frank about friction, that this really does exist. Security engineers can sometimes feel that developers are negligent. In fact, if you see some of those old interviews or interviews with older security people that have been around for a really long time, you'll often hear them say something like, the software is full of bugs that should not have been there in the first place. And while this is true, it's a little bit of a naive viewpoint, but if we flip the script, developers might feel like security is incompetent because they try to undermine decades of empirical process. And the way that in security, sometimes we do this is by trying to enforce SLAs on line level fixes, thinking that somehow bypassing the process and doing things faster will have better outcomes. So something I want to make sure that I acknowledge here too is we're not looking at soft skills here. Soft skills really do help, but what we're going to do is we're going to go a little bit deeper and strip away the soft skills. We're going to reach directly into their minds, into developers' minds, and try and make them do security without them even thinking about it. But just like in the movie, if we're indelicate about this process, their subconscious will attack us and we'll end up in limbo. We'll lose their cooperation, essentially, and we really don't want to be in that situation. So to get past that, we're going to try and understand what motivates them, and we're going to strip away that layer of where soft skills are effective, get down to an even lower layer, and examine first principles. So first of all, we'll take a look at this first principle of software or of security. And we've talked about this from this stage before many times, but the first principle of security is reduce the probability of material impact. So we'd like to remove all chances of a breach, but that's just not really possible. That's not realistic. We could, take the classic illustration of taking the computer, putting it into cement, and then sinking it in the ocean. It might make it secure, but it's not functional. So we have to acknowledge that businesses don't exist just to be secure. They also exist, of course, to do business. So we have to align our business or our security strategies with the business goals. And this is a balancing act that we get better at as we go. Then let's talk about the first principle of software engineering. Software engineering really does have to go beyond just solving problems with code, which you might think first is their motivating factor, but they have to have long-term value so that it has business value. And otherwise, their code that they write is just single use and disposable. And to emphasize that's not important to software engineers, right now you see a lot of offloading of this disposable code to artificial intelligence. It'll write a script, execute it, and then you'll never see it again. So in order to align with the business and to show that value, they have to resiliently add computing value. So that's the first principle of software engineering. And so without getting too deep into this, analyzing these two, we can just summarize that software engineering is creating value and security is trying to defend that value and to preserve any other value that the business finds in other things. So they really don't conflict. So this inception is possible because there is not actually a conflict. So why is there friction? Well, this also has been said from this stage before, but sometimes in security, we get so excited about the security things that we forget about the business goals. And we do need practitioners to push forward and to push these security things, but we're not going to engage with business groups unless we understand and align with their purpose for existing. And this is especially the case with development. Development already has a direct business feed. And so we need to acknowledge this and align with it and follow through on the ground level for explicit alignment with that. And that's part of what we'll talk about today. So now that we've examined first principles and we know there's not a conflict, so we can implant this idea, I want to talk about a couple of misconceptions or things that might trip us up as we start to go into this process of creating this implant. The two things are the motivation for flexibility and handling this work feed appropriately. So first of all, the motivation for flexibility is really something that isn't often considered by security. A programmer doesn't really start to be productive until they learn to layer together flexible code. And in my case, when I started to do this, I spent less time fixing bugs that I had created. And I really started to enjoy the process of making and building and maturing my product. This flexible code is really what makes software engineers able to make less excuses when they're asked to implement functionality, when they get feature requests. And you'll see this as they develop. Early on, they'll make a lot of excuses, but as they get good, they'll make less and less excuses, and they'll be more confident in responding to bug fix requests. In fact, sometimes they'll get the request and they'll think in their head, just right there, oh, I know where that's at. And so they'll be able to go fix it. In fact, early on when I hit this level or this layer of being able to use flexible code, I felt like I had developed a minor superpower because I was able to go back to older code and I was able to leverage that flexibility to do other things. And what was really great about that even further was that when other people went and found my code and layered their flexibility on top of it, it really felt like the code was coming to life in their hands. And it's a live moment that separates the builders from the breakers and the hackers from the makers. Because of this, once a developer achieves this, once a software engineer achieves this, they will try and do it again and again. Not just because it's thrilling, but because it's profitable and it's really productive for them to be able to do this. Unplanned functionality, though, can be a point of contention. You might think in your head right now, you might be thinking it's not a bug, it's a feature. That's related to this, but this is more the motivation behind creating flexibility. That this flexibility or the value of flexibility could be confused by us in security. It could be confusing to us because as we're testing, we may be looking for untamed flexibility in order to gain access to data that we don't think we should have access to. And we may think that developers should be ashamed of this flexibility in the code. In fact, we may even equate flexibility with insecurity, and that's not really the case. Because something that we have to acknowledge is that security is not implicit functionality. Coincidentally, this is why when you ask generative AI for code, it's not the only reason why, but one of the reasons why when you ask for code from generative AI and it gives you code that's insecure, it's because you didn't ask for it to be secured in a specific way. So this is, there's a parallel there. So while software engineers really do need to learn to tame their monster, they might not, it might not be in the way that us in security may think that it should be done, and it's probably not for the same reasons. So the bottom line here is accepting that security is not implicit functionality. And we're going to build on that a little bit as we go. So if we're mindful of this, then we can make sure that this implant actually works. So another place that may trip us up is shoveling left. And where shoveling left comes about is we're busy, like I acknowledged before. And so when we're busy, we try to offload some of these activities. And this makes it easy to get caught up in what I call shoveling left. So what is shoveling left? It's supplying impractical information and leaving the responsibility on the developers to make sense of it. So to give you an illustration of, or an example of where this can happen is when you have a application security testing tool that integrates directly with something like Jira, and you're able to make the results go directly into the developer's backlog. And we wire it up to do that. And some of us have found success in this, and you initially might, but eventually you'll find out that it's a lot like mowing grass. You'll knock down or check off some vulnerabilities, and then pretty soon, oddly, specifically very similar bugs will come back, vulnerabilities will come back in the same place. And the reason for that is this, using the information this way, unfiltered results back to the developers, requires them to figure out what to do with it. And it's very false positive prone. It doesn't really scale because it's noisy. And so it can be really disruptive to the developers, pretty much like sending a freight train through a packed downtown intersection. Excuse me. The raw information out of a security tool, the reason for this is that this raw information is never going to be as actionable as the developers really want it. The vendors try and, it's not the vendor's fault, they try and give you as much information as possible. And sometimes, it's too much information. But what the tool doesn't know is your architecture. It doesn't know your style of code. It doesn't know the personality of your team. And so they really don't know what's actionable for you. And someday we might have, an artificial intelligence system that will fill in this gap. But in my opinion, LLMs probably won't be able to do that. But we really want to make it as actionable as possible. So when they aren't actionable, those items will just sit in the backlog. And as feature requests come in, that backlog will push the vulnerabilities down into the bottom until they end up in what we might consider to be limbo. And as a reminder, just like the movie, if we trigger the subconscious rejection like this, we'll end up in limbo. And shoveling left is the sort of thing that can really damage our reputation, and it'll cause problems with our ability to work with developers. We can get trapped in limbo, and that can keep us from making any sort of meaningful impact. And so some of you may actually already be in a situation like that where you're having trouble making impact with development. And hopefully you'll be able to pick up some things today that will help you get past that. But if not, I would love to hear about it afterwards. Oh, and by the way, this is our plan. I will assemble some notes on the left-hand side, and then on the right-hand side, this will be the steps to the implant. And we'll build this as we go, and I'll remove the redaction as we go, just to keep things a little bit suspenseful. So we're going to make up a target company so we can talk about it figuratively. The company's name is Fisher Morrow, and they have a very large attack surface. They have all kinds of sensitive data. They have PII, PHI, credit cards, anything imaginable that you can that's sensitive. And they have a lot of intellectual property. In fact, their custom code takes care of all their customer interactions and most of their internal processes. So that attack surface is really big. They have a moderate-sized development team with around 700 developers, and there's about 330 code contributors. Now, the reason I point that out in this fictitious company is that I want to acknowledge that there's other roles within development that are not programmers. There's product roles, there's quality roles, and various aspects that some of which we won't talk about today, but we need to be mindful of those because who we're targeting for this implant is really the programmers, and in fact, a very specific type of programmer. So I'm going to break down programmers into 3 basic types, and some people like to categorize them differently, but just for our case here, I'm going to talk about 3 types. This first type is the type that doesn't really care about getting better. They don't care about the quality of code, and really all they're doing is trying to get paid. That's all they're there for. And they'll say things like, if the customer doesn't complain, it's not a bug. And I don't know if you've ever heard that before. I have. And that's a little bit disturbing, but they are the reason for protected branches. But don't confuse these ones with people who are learning. People who are learning may go through a time period that looks like this, but you should give everyone a chance to prove that they're not like this type of programmer. The second type of programmer, maybe many of you in this room are, they're building their skill set in order to be in a different role. Really, they're targeting something else. They're not going to spend the rest of their career as a software engineer. And in fact, if you're working to get into the security for a career, I would recommend spending a couple of years as a programmer or a software engineer and just so you can kind of get a lay of the land and see if you enjoy it. Maybe you'll spend a couple decades there like I did.
Good.
But something to point out here is these first two types are not core engineers. They're not the ones that drive the process. They're not the ones that make decisions. Really, it's down to this last type. And I gave two different examples there. We have the Ariadne of the software engineering world, or the Eames, if you remember the characters from the movie. These characters, or these programmers rather, enjoy making. They're probably good at it. They definitely want to get better at it, and they might enjoy the way that everything relates to software, and they like being able to see things from behind the scenes like that. For those first two types, again, the inception won't really take effect unless this third type accepts it. We can think of the first two types as NPCs, or like the subconscious. They'll still turn on us if we provoke them. But this third type is really where the business of software engineering, or the software business, stands on their shoulders. It's this is their dream world, if you will. And so this is where we need to focus on for the implant to begin with. So what is the idea that we're going to implant? Well, we know that it has to be the simplest version of the idea for it to stick. Security tends to speak authoritatively. A lot of times we're very confident. So if we use old school requirements language or a command, we say something like development shall create securable software, that's really not going to take effect and really be accepted by their mind. What we want to do is engage their mirror neurons, and we want to help them understand that their team is doing a measure of security already, and they are too. This is a little bit akin to gaslighting, but it's more along the lines of Hellenization. We want them to think, I am creating a securable product. And then what this does, if they're clear about it, and if they're confident, and they know that they are already capable of producing secure software, then their desire to get better will be hijacked, and they'll work at getting better at security. And so the message, again, that we want them to be thinking is, I am creating a securable product. And this isn't a trivial task to do this. So I'm hoping that as many of you as possible are up to the task. So as we enter into the first level, we want to ask, how do we set them up for the implant? Well, what we're going to do is we're going to challenge them with a problem, and then we're going to give them a tool so that they can see that they're already solving the problem to an extent, and then that they can do even more on their own. The problem we're going to present them with is that there is no static state of secure. This means that they have to create securable code that operates in a secure way and can be configured in a secure way intuitively, and that can be maintained. So it wouldn't seem genuine if we just pointed this out. So it needs to be their idea again. We don't want to trigger their subconscious rejection. Ideally, we'd use a tool that they are already familiar with, maybe something that unfortunately we might not be comfortable with because it's outside of our testing-centric world. So we have to be sure that we're prepared for that. So what would be nice is to use a model that's familiar, that doesn't need translation. We know in security we use a lot of jargon and testing-centric language, so it's likely to trigger their subconscious rejection. So here's the software, the complete software engineering context. And in the past, I like to point and say, there we are. We're in there. You're already, those are commonly used attributes of software. For completeness, this is what this framework is for, ISO 25010. But the problem with that is that while those attributes address security specifically, it's not all the attributes that are needed for securable software. So that's where the securable software engineering model comes into play, the SSEM. This is taken from the OWASP project phase. I pronounce it phase. It's the framework for integrating application security into software engineering. And you can check it out on OWASP's site, but these attributes are express security concerns, but in software engineering language, in a standardized, well-established terminology. So they can understand this without years of security experience or translation. So how do these attributes address security? Let's take a closer look here. In the past, I've been asked, can unmaintainable software be secure? And the answer is no. First of all, because there is no static state of secure. But secondly, because if code's not maintainable, it can't be changed with confidence, and therefore it can't be secured. But the other thing that you might be thinking right now is that maintainability is not AppSec's responsibility. And if that's what you're thinking right now, I want to give you a virtual high five, because that's essentially you're starting to get it. And this is really the point of this framework, is for software engineers, because they're the only ones that can really influence securability of software. So with how this pertains directly is that software has to be able to be analyzed. Code needs to be able to be analyzed in order to be understood, so that they can find, so that anyone can find the problem in the code. The code has to be able to be changed confidently without breaking other things or adding vulnerabilities. And then it has to be able to be testable to prove that the code change fixes the problem. And ideally, testability means that it would be testable units. And if you break down the code into testable units, it also makes it easier to threat model, which we talked about a little bit in the last talk. This is the most fundamental and universal attribute of securable code, is maintainability. Again, if it's not maintainable, it can't be secured. And merge reviews is how this is verified. So this actually does take the involvement of software engineers, in addition to this model being for software engineers. So this is one of my favorite Martin Fowler quotes. Any fool can write code that a computer can understand. Good programmers write code that humans can understand. And the point of that is that if you're writing maintainable code, you're not hiding functionality in clever code on a daily basis. And so when somebody does try to hide functionality in clever code, you can identify it. It doesn't look like the rest of the code, it stands out. So in this day and age, it's very important for this, not only because of generative AI, but also just malicious actors getting into your code. If they do something clever, you should be able to say, how did that, where did that come from, and do a blame on it and track it down. In fact, I think it was the PHP problem a couple years ago. That's how they found it. So trustworthiness is something that is instantly relatable to us in security. But the hard part of it is that it's hard to map to code. The reason for that is because it requires cooperation between the modules. It's a systemic, higher level attribute. In order for programmers to create trustworthy code, the architecture has to be clear to them, and they have to understand the way the code is intended to exhibit these attributes, or how it's going to carry out things like authorization or security features. So it's easier with clear architecture, and cooperation is required. So if you're not doing some sort of planning up front, if you're doing agile without any documentation, no planning whatsoever, in my opinion, you're not going to be able to create securable code. So you need to be doing some sort of planning and documentation up front, because this requires transparency on both sides of the creation process to verify trustworthiness. Then reliability is definitely a system level attribute, but it does require the other two to be in place in order for you to even consider having reliable code. Reliability, just to quote the definition here, it says reliability promotes the ability to keep running predictably under unfavorable circumstances and load. So you can understand how this embodies everything else and very much is dependent. In fact, I like to point out resilience as just a minor quality or a minor attribute of securable code. And it's gotten a lot of news coverage and things lately, but really it's only a piece of the picture. And I would encourage you not to overemphasize resilience because it depends on everything else before that. So this might be something that this framework might be something that we're not necessarily comfortable with in security, especially if this is the first time you're seeing it. But in order for us to get comfortable with it and to understand it, it might be good for us to take a look at each one of these terms and understand the standardized meaning, and then take a look at it and ask what can go wrong and with this particular attribute, and kind of understand what if it's not doing this, what problems can it cause. And then also when you're doing threat modeling, you might ask what can go wrong, and when you try to answer the question, what can we do about it, consider the SSEM and see what attributes could you emphasize in order to fix that problem. So this really changes the conversation with development from is it secure or blasting them with test results. We can then have a conversation and ask, does a given piece of code meet our goals for this particular attribute? And this is a much more productive conversation, and it's also very specific. It's tantamount to, did we do a good job, but even more specific. And as a side benefit, these attributes work really well in prompt engineering because they embody a lot of implicit attributes because of the definitions of this. So if I actually put this in my configuration, and so as it's generating code, it'll actually tell me what attributes that it's considering as it's generating the code, or if it needs to do more in later steps. So in spite of this is a really functional, very broadly applicable model. But we have to acknowledge that best practices aren't enough. We need more information in order to know that our software is secure. So this brings us onto this second level where we're going to feed the idea by enhancing their process, the development process. And as we go deeper, remember, it's not just about depth. For us, this level consists of many small ideas. So we have a couple of purposes behind the extension of processes. The first is we need more information, and we can get it quickly if we're involved in the process. And the second is that development also needs more information. And if we can give that to them when they want it, we don't want to necessarily blast them with it. Like, we don't want to shovel left. But if they want more information, we should be able to provide it. Because we don't want to be disruptive, and we don't want to be noisy. Because, again, we'll trigger their subconscious rejection and end up in limbo. And if you didn't catch it when I said it the first time, being involved is really key to this level. It's better than validation or assessment, ultimately, when we're talking about developers being involved in the process. So here's a few software engineering strategies. And you might be looking at this list and you might already be thinking about ways that security can integrate in with these strategies. But I encourage you to really get to know your environment first, know your target, which is something that you might hear a lot. And in that way, you can be specific to what your needs are. Excuse me for just a sec. So our target company, Fisher Morrow, the architects might be really concerned about high availability, which a lot of systems are concerned about this. So we can align with them by bringing in reference architectures. There's a lot of sources for that out on the internet, and we'll talk about some of them later, but we can help them out because we're concerned about DDoS, and we can definitely help with on the architectural level. When I like to think about completeness, I think about what happens when there's gaps in requirements. Some agile frameworks just want you to iterate a bunch of times until you fill the gap. But if you're not filling the gap, eventually that starts to cost more than the creation process is worth. And this is especially the case in security. So we want to not be brute forcing the situation, but we want to supply some of those security requirements up front. So, for example, Fisher Morrow might be having failures due to invalid input. They might be seeing excessive errors in their logs, or they maybe we gave them some test results. We showed them some test results that show that they have inconsistent application of their authorization. They might have some IDORs out there or whatnot. So the two things that we can do, just like before, we can take a look at those reference architectures, and there's actually all kinds of reference requirements out on, especially OWASP's website, that we can bring in to help with that. But something that we can do on the requirements side is give them checklists so that they can be sure to completely develop a feature, including the security requirements that, again, aren't implicit. And one thing that I don't see enough from my perspective is the sponsoring of initiatives in order to broadly make changes to the software, bake things right into the framework. Had a conversation about this just a little bit earlier too. And so doing that can make it easier for software engineers to do it the right way. Now, transparency, when you see transparency, I want you to think instrumentation and logging and tracing. And what I like to use as an example here is 3 Mile Island. If you're familiar, 3 Mile Island is a nuclear plant in Pennsylvania. And it was said to have never less than 52 alarms blinking at any given moment. So they had a point where the reactor started to fail. And at that moment, over 100 alarms went off. And so that 100 blinking lights, and they didn't know the difference between the ones that were normal and the ones that were new and important. And if you watch any of the documentaries on it, it spirals from there, and it just caused a PR mess as well as some environmental issues because of this. So this might be familiar to you. Have you looked at production logs and you see periodic errors coming through the production logs? And you ask somebody like, what's this error? And they might say, oh, that just happens from time to time. So if you're having a breach, if you're in the middle of a breach, are these errors going to hide actual useful information? Is it just going to be noise? So it's something to think about. We want to know when we talk about those little blinking lights, we might have indicators, but we need to know what they mean, each one of them. We need to know why it was triggered, when it was triggered, how often that happens. So if this is something rare, then we need to look into it. So we have to have that level of information. It has to be that transparent. And this is important for, of course, incident response, but also when we're trying to successfully perform and get information from a pen test. And this can just help out on everyday issues, to be quite frank. So for an example, our target company, again, Fisher Morrow, they had an incident that came from a service account. And they think that one of the applications that ran under the service account was the reason. They thought that it might have been breached, but they don't really know because they don't have enough information. So again, something to do in circumstances like this is to sponsor initiatives to fix the problem And in a circumstance like this, that may be the only way that they can address the issue, is to actually take some time, put it aside, and fix the issue. And I don't quote me, but I think that was part of the problem with a few issues at MySpace in the past. So I'm sure you're getting the basic pattern of things, the embrace and extend idea. And as I note there, don't forget the metrics. So try and keep track of things as you're going so you can see your improvements. And this is not your outdated lift and shift sort of style of shift left that we talk about a lot. This is extension of existing processes in a transparent way. And also, you can't add security to what you don't know. And so you have to know your target, know your environment, and do research there. So to go back to OWASP phase, software engineering can help out, or can be helped out in several different ways if we encourage engineering to do things like merge reviews, because merge reviews help to improve software engineers as well as code. And so I think it's underused in security, to be honest, underemphasized. And it never hurts to ask what can go wrong, and this framework emphasizes that. In fact, it encourages you to do it even at a line level, to think about like what can go wrong with this line of code. Dependency management is something too that isn't really leveraged enough nowadays, and it's becoming more and more important, as we've seen in a couple recent breaches. And we can use the SSEM to evaluate dependencies rather than just mindlessly including them. And that can help us make that decision whether to borrow, buy, or build. Just asking what can go wrong really ultimately is really useful. And it also emphasizes, OWASP phase emphasizes security participation over assessment, because having security involved when things are being planned, of course, is extremely useful. So to review a little bit, we framed the idea of security with the SSEM, gave them a tool so that they can recognize that they are doing a little bit of security already, regardless of how much they're actually doing. And then we supported that idea through some process enhancement. Now, as we enter into level 3, we have to be really careful because things can get confusing. In fact, I think it's an interesting factoid in the movie Inception. In some areas, the release had numbers to let you know what level you were on between the different scenes, so you could keep track because audience were lost. But so this can happen once we get to this stage. What we're going to do is drive secure development subconsciously in software engineering. We're going to set security expectations very clearly and practically. And to do this, you may already know how, but we're going to embrace that security is not implicit functionality. And to do this it's a lot less work than you might think. We can reach out to different OWASP projects like the Mobile Application Security Project or Authentication and Authorization Cheat Sheets. There's the Application Security Verification Standard and the Software Component Verification Standards. Those all include software requirements that we don't want to just dump them into our own applications, but they can be used as a reference in order to guide us as we help build requirements. So leveraging requirements, or the requirements activity, is a lot like injecting security into the source of work or the lifeblood of development. And so we want to be careful to handle it with care. We want to use caution so that we don't conflict with the business, because if we conflict with the business and they put us into limbo, it's a whole other level of non-functionality. It's a lot worse place to be. Now, and I want to be really clear about requirements too, that when I say requirements, I don't mean monolithic reams of paper that are everything is decided up front. Agile just doesn't work that way anymore. Or software development, even if they're not doing Agile, really doesn't do that anymore. we want to be sure that we're adapting to however that's functioning in our environment. We want to be cautious about adding too much to the load of documentation. Development is very cautious about creating documentation in general, but we want to, again, be involved in the process helps with this. And requirements, like I said, are gathered in various different ways. We have to know our target and match the internal process. And here are some of the ways that it can be gathered. You're probably familiar with these. Having some sort of acceptance criteria can be really important. We can participate in user stories, use cases, but then also some security things just don't fit in those boxes, in those formats. Then we can use threat scenarios. And again, all these things need to match the pattern that they're using internally, because if we do this, then when development gets them, they're just going to work it like any other task, and they're not even going to think about it as its security. They won't think twice. So here's the formula. This is the slide. I'll pause here for a second and let you take a picture. So this is how we infect every level of a developer's mind, as well as the process. If we do this right, we'll make sure that it will appear that we are very concerned about the advancement of development as well as security. And so even in that way, it'll look transparent. But now, if we've performed the inception, then what comes after is the kick. And this is like dipping us into cold water. But you may have noticed that most of what I've talked about are security changes on the security side. And so this may be a significant shift for some practices, but this will also bring us into the era of product security. And this pertains to internally developed code as well as external products. And it also pertains to traditionally written code or AI-assisted coding. Product security really takes an active role in the product team, the architecture team, obviously engineering, QA, and operations. They interact with all layers of software and in a structured way. And if you're not doing something like this already, I would encourage you to look into it further, do some research, see how you can do it in your environment. So this sort of scenario isn't like having to choose between like having a house or having an apartment. You can be both. You can be on the security side and participate in the creation process. The way this is possible is by embracing the assurance nature of AppSec and getting skillful about what we do with the information that comes out of assurance. We want to promote this cross-functional practice of product security. We can use that OWASP phase framework for developers, but then also to frame how we interact with development. We can move past the trivium of shoveling left, and we can do this without being disruptive and without gimmicks. Thank you.
Yes, Robert.